Hello guys and welcome back to chemistry. I hope you guys are doing well. So this is your last video of notes for the chapter. Your chapter test is going to be next Monday and Tuesday, depending on when you have my class, A day or B day. But just go ahead and check the calendar on my Schoology page just so you can keep on top of that. Also on the calendar I have 2 Zoom sessions. Those are kind of penciled in right now, kind of depending on my schedule, but I am going to do 2 review Zoom sessions. They're completely optional, but just keep updated on Schoology. By Thursday of this week, I will have a better idea of when those Zoom sessions, Wednesday. By Wednesday, I will have posted when those Zoom sessions will be, because they'll be on Thursday and Friday. I'm just trying to nail down a time, so keep an eye out for that. So today we're going to learn about dilutions. So picture that you have in front of you a glass of the world's best lemonade. It's just so perfect in every way. Delicious lemonade. Sounds lovely with the nice weather that we're kind of getting in right now. And then picture that I take that glass of lemonade and I add it to a gallon of water and then tell you to drink that new solution. I think all of us would be pretty bummed because that perfect glass of lemonade would get super, super diluted, right? The flavor would kind of just be washed out by the water. So it's exactly what we're talking about today, is when a solution is made less concentrated by adding more solvent. So in that case of the lemonade, I added way more water. So something that you're kind of familiar with when in cooking a lot. We do a lot of dilutions in cooking. An important thing to note in chemistry, well, in all dilutions, but specifically in chemistry, the number of moles of solute does not change. So think about the powder that I used to originally make that lemonade, to make that perfect glass of lemonade. Let's say I used 1 scoop of powder. When I added all that water and diluted it, I didn't change how much powder originally went in. So like I said, the amount of solute in the beginning did not change. When a solution is diluted, all you're doing is you're adding more of the solvent. So it's along with that note is the moles before diluting equals the moles after diluting. So again, that directly relates with that idea that you're not changing the amount of solute. And in chemistry, we measure amount using moles. So the moles are unchanged, the moles of solute. So this right here, let me change my highlighter color so maybe it looks a little bit different. This right here is the equation that you're going to want to use. M1 times V1 equals M2 times V2. The capital M, remember again, stands for molarity. And the capital V, in this case, stands for volume. And that's volume of the whole solution, so solute plus solvent. So what happens when I take molarity times volume is you get the number of moles. So we can say that molarity times volume in the first half, the number of moles that we started with is equal to the number of moles that we end with. And that's just because the only thing we're adding in is water, and that's not the solute, that's the solvent. So again, this moles of solute is not changing when we do a dilution. Okay, so again, M1 times V1 equals M2 times V2. Let's go down and do a couple example problems. Since there are 4 variables in most every problem, you'll be given 3 of them. So I like to make myself a list. M2, V2. Those are all the variables that I'm going to be looking for in the problem. And as I find them, I'm going to just write them into my list. So example number 1, we want to prepare 500 milliliters. 500 milliliters is a volume. Now this is an important thing to note. When you are doing these dilution problems, the units don't matter as long as they match. So units must match. So there's lots of ways we can measure volume. We can measure it in milliliters, we can measure it in liters, we could even measure it in kiloliters. Lots of different measurements, but as long as your units match, you will be fine. So units don't matter except that they have to match. So back to the problem. We want to prepare 500 milliliters of a 1 molar, so 1 is the molarity, and that capital M, you use the word molar like your tooth. That's how you would read it aloud. So we want to prepare 500 milliliters of 1 molar acetic acid from a 17.5 molar, so that's my second molarity, solution. A stock solution is just a solution that you're starting with of acetic acid. What volume, so now it's asking me to find what volume, so V2 is my question mark, of the stock solution is required. So we're just going to go ahead and plug it into that equation then. So M1 is 1.00 molar, V1 is 500 milliliters, equals M2, 17.5 molar, and V2 is X. So now we just need to solve for X. So 1 times 500 is 500 equals 17.5 X. To solve for X, we do inverse operation. So it's currently being multiplied. So we'll divide by 17.5, divide by 17.5, and 500 divided by 17.5, X equals 28.6 milliliters. So remember I said that the units must match. So since this was in milliliters, this is also in milliliters. Now, so that tells me that I would take 28.6 milliliters of my super concentrated stuff and I would add in water to dilute it. And I would make it less concentrated, down to 1 molar. Now we can actually figure out how much water we would want to add. We know that the total volume at the end of it is 500 milliliters. That's the total. And that's going to be 28.6 plus X. That is the amount of water that we're going to be adding in. So you just subtract 500 of our total final solution, because that's how much we want to prepare. 500 minus 28.6. When you enter that into your calculator, you get that we're going to add in 471.4 milliliters of water to do that dilution. Okay? So that's first example problem. Second example problem. If you dilute, well, first of all, before I start, let me write down my list again. M1, V1, M2, V2. So if you dilute 175 milliliters, that's the first volume I see, so I'm going to write it down, of a 1.6 molar solution, so that's my first molarity, and those two go together, with 100 milliliters of water. So that is actually not my V2. That is not V2. Nope. That's telling me how much water I added in to do the dilution. Your second volume needs to be the volume of your final solution, not just the solute and not just the solvent, your total volume. So if we started with 175 milliliters and I added 100 milliliters, you are going to end up with 275 milliliters. Then it says, it's asking what will the new molarity be? So M2 is question mark. So go ahead and plug this into your equation. 1.6 molar times 175 milliliters equals, we don't know what M2 is, and then our final solution volume is 275 milliliters. And again, we check our units do match, and that's good. 1.6 times 175 is 280 equals 275x. Do the inverse operation, which is dividing by 275. 280 divided by 275 is 1.02 when you round, I think. Let me plug that in my calculator one more time. Yep, 1.02, and that is a molarity, and so the units that we use are capital M. And that one we're actually done because it's the final molarity. So those are two example problems similar to what you'll see on your homework for today. So go ahead now and work through homework number 4. Again, the answer key is provided so that you can check your work. And these questions, you actually don't have a quiz on these questions. You'll just see these types of questions on your lab that you'll do on Thursday and Friday of this week. And then you'll also see these types of questions on your test next Monday and Tuesday. So please, again, email me if you have any questions, and keep an eye out on Schoology for my optional Zoom sessions before your test next week. Hope you guys are doing well and that this makes sense to you and you're rocking chemistry, and have a great rest of your day.